Ooh, all right. Here's the pre-calc test study guide. I'm going to go through it page by page. For this page, though, I'm going to be switching between a blank sheet and the test sheet. So let's get to the top here and let's go for our first problem. So we're looking at A times B. So we need to write down A and B. So this first one is 1A and it's A times B, right? So my A is 1 to negative 3, 1. That's my A. And then my B is 11, negative 1, 4, and 3. And this is B. So before I do anything, once I know that I'm multiplying, I need to check the dimensions. So this is a 2 by 2, 2 rows by 2 columns. And this other matrix B is the same. It's a 2 by 2. So now, when I'm multiplying, I check the inner two dimensions. They have to match or be the same. If those two numbers are the same, then my answer, or excuse me, the dimensions for my answer are going to be these two numbers. Or you know what? Let's even get a little fancier, and let's say it's the dimensions for the product, because the product is the name of the answer to a multiplication problem. So we're going to multiply these two things. Let's make this a little bigger. So we're going to multiply these two things, right? And we're going to get a 2 by 2 matrix. So to start, I'm just going to give myself sort of like a little 2, 2, and 2. I'm going to give myself a 2 by 2 spot. Now, I sort of described, I had a little diagram that I went through. I'm going to do that after I go through this first one, so I hope that's not confusing. So, what do I got for this one? I have, when you multiply, remember matrices is the plural of matrix. So, more than one matrix, then you call them matrices. So, multiplying matrices, um, you multiply row times column and go, let's see, what are we going to call these? Numbers or go term? We go term by term, adding them up. Okay, so this is multiplying matrices. So, and this is after I got made sure that my dimensions were straight. So I'm going to take the first term and multiply it times the first term here. So that's 1 times 11 plus 2 times 4. Then I'm going to take 1 times a negative 1. I do that every time. Put my dot and then I draw my negative right on top of it. So 1 times a negative 1 and then 2 times 3. So that's plus 2 times 3. Then I'm going to go to the second row. So negative 3 times 11 plus 1 times 4. Then I'm going to have negative 3 times negative 1 plus 1 times 3. So now I'm just going to simplify this. 1 times 11. You know what? I'll just take some time on this. So I got 11 plus 8. I've got negative 33 plus 4. I've got a negative 1 plus 6. And I have a positive 3 plus a positive 3. So then my final answer is going to be 19, 5, negative 29, and 6. This is my answer. This is AB. or A times B. All right, so let's see what's next. So next we've got, sorry, 1B. So 1B says G minus H. So this is G101, 3, -1, -2, 0, 2, 1. So that's G minus 1, 2, 3, 2, 3, 1, 3, 1, 2. That's H. So now we're subtracting. So we start with looking at the dimensions. This is a 3 by 3 matrix, 3 rows by 3 columns. And this is a 3 by 3 matrix. So when adding or subtracting, well, you know I mean adding and subtracting. So add or subtract matrices, the dimensions must match. And that's going to give me a corresponding 3 by 3 matrix. Now I say corresponding because if I look at the first term here, there's a first term there. I subtract those two. I have a second term here. I have a second term here. Now, before we were going row and column when we were multiplying. Now we go term by term that correspond to each other, right? So we're going to have 9, right? Right. So I'm not going to do that though. Okay. So add or subtract matrices, dimensions must match. And you go term by term. So this is subtraction. So I've got 1 minus 1, 1 minus 1. I've got 0 minus 2, 0 minus 2. Let's give myself a little more room. And then I've got 1 minus 3. So next I've got 3 minus 2. Then I've got -1 minus 3. And then I've got -2 minus 1. Okay, last I have 0 minus 3. I have 2 minus 1. I have 1 minus 2. And then I just simplify. 1 minus 1, 0. 2 minus, or 0 minus 2 is -2. 1 minus 3 is -2. 3 minus 2 is 1. -1 minus 3 is -4. -2 minus 1 is -3. 0 minus 3 is -3. 2 minus 1 is 1. And 1 minus 2 is -1. And here's my answer, G minus H. All right, so let's see what we got next. Okay, so next we got 1C, C times W. Now remember, with matrices, order matters. So that's why I'm writing it out like this. And we got to make sure we follow it right. So C is 2, 1, 3, 4, 1, 7. And W is 2, 1, -2. So what are the dimensions of this? This is a 2 by 3. So C, that's a 2 by 3. And then I look at the dimensions here. 1, 2, 3. So that's a 3 by 1. So I look at my inner dimensions. Hey, they match. And then my result is going to be a 2 by 1 matrix. So that means I'm going to get something Just give myself a little space to work out. So what that means is I'm going to take this whole row and multiply it by this column. Then I'm going to take this whole row and multiply it by this column. Now remember, each individual one is being added. So I'm going to have 2 times 2 plus 1 times 1 plus 3 times a negative 2. So all of those added is going to be my first row. And then my second row is going to be 4 times 2 plus 1 times 1 plus 7 times a negative 2. So let's go ahead and simplify this. So I'm going to have 4 plus 1 minus 6 and 8 plus 1 minus 14. So 4 plus 1 is 5. 5 minus 6 is negative 1. And then 8 plus 1 is 9. 9 minus 14 is negative 5. And so here is my 2 by 1 matrix. That is C times W, or CW, I guess you could say. All right, so next is 1D. 1D is X times D. So X is 2, negative 1, 1, negative 2, times D, which is negative 1, 0, 4, 3, 1, 1. So this is X, this is D. So the dimensions of this is 1 row by 4 columns. So that's a 1 by 4. The dimensions here are 2 rows by 3 columns. The inner dimensions don't match. So no solution. NA can't do it, or not possible. Whatever expression that you can't do it, however you want to say it. All right, next I've got 1E. U minus E. So U is 1, 7 minus E, which is 1, negative 1, negative 2, 0, 1, negative 2. So I look at the dimensions of U and E. This is a 2 by 1 matrix. This is a 2, no, oops, sorry. Got ahead of myself. This is a 3 by 2 matrix. We're subtracting. Subtracting says that my dimensions have to be the same. Well, they are not the same. So because they're not the same, no solution. Can't do it. Not possible. Okay. So now we've got 1F and 1G. So we need to look at G first. So G is a matrix 1, 0, 1, 3, negative 1, negative 2, 0, 2, negative 1. So 1F says we're looking for matrix G with the subscript of 2, 1. So that means I'm looking for row 2, column 1, right? So row 2, column 1. So this equals 3. 1G. What is G of 1, 2? So that is row 1, column 2. So row 1, column 2. That's 0. Now I'm just going to throw an extra in here just so you can get a little feel. So I got G of subscript, let's say 3, 2. All right, so 3, 2. I go to row 1, 2, 3. So I'm down here, getting a little fancy with this last one. So I'm down there, and so now I need to go to column 2. So 1, 2. So where the two colors meet, that's my answer. So that is 2. All right, I know I got fancy for the last one, but if it'll help you see it better, let's use the marks or the colors to do both. So G of 2, 1. So I go to the second row, that's this one, and then I go to the first column, that is this one. See, 3. And then blasé. All right, so the last one, I go to 1, 2. So first row, second column, and there's my 0. So that's all of those. Well, I need another sheet so we can talk about problem number 2. All right, so problem number 2 says, find the missing side lengths for the following right triangles. So I got a right triangle that looks like this. Right triangle, that little box tells me it's a right triangle. 30 degrees with 12. And I got one over here that looks like this. 45 degrees. It's got the box. And I got a 6 right here. So I labeled these sides Y and X. I probably should have labeled them a different letter in this Y and X. All right, so let's talk about these. These are special triangles. Special triangles, right? There's a 30, 60, 90 triangle and a 45, 45, 90 triangle. So just so you know, this angle is 60, this angle is 45. So that's where the names come from. So in a 30, 60, 90 right triangle, which we're going to give ourselves just a little bit of room. We're going to write it down here. There's a certain pattern that happens. So if, well, you know what? Let's draw it in the same direction so things will make sense. So let's go like this. So if I have a right triangle that is a 30, 60, 90 triangle, right? There are certain side length patterns that happen with this, okay? And they're all based off of the side that's across from the 30-degree angle. So we're just going to call this, we're going to call it C. So that's my whatever. I don't know what the number is, but it's C. So then the hypotenuse, the side that's across from the 90-degree angle, that would be 2C, okay? And then the side that's across from the 60-degree angle, it would be C times the square root of 3. So for instance, if I gave you a 30, 60, 90 triangle, and I said this length was 5, because that length is across from 30, I know what the other two are. The hypotenuse is 2 times that value, so this would be 10. And then the side that's across from 60, that would be 5 times the square root of 3. See how that works? See? That's the pattern. Here's if I just put in this number, I knew 1. That's how I get the other two. All right? So let's get rid of that blah, blah, blah. So now let's put this in terms of that. So when I look at the pattern, the side length that's across from 60 is C times the square root of 3. Well, I have that. I've got 12. So I'm going to set up an equation. 12 equals c times the square root of 3. I need to find c. All right, so you isolate c. C is being multiplied by the square root of 3. So I'm going to divide by the square root of 3, and that will isolate c. So in order for my equation to be balanced, I have to divide by the square root of 3 on both sides. Then these two things are going to cancel off. So then I'm going to have 12 over the square root of 3 equals c. Well, that's not good enough. So what I'm going to have to do next is I'm going to take 12 over the square root of 3. And the reason I said that's not good enough is because you can't have a square root in the denominator. So I'm going to rationalize. So I want to think of the smallest thing that I can multiply this by to get rid of the radical 3. Well, in this case, it's radical 3. Sometimes there's other ones that you can multiply, but in this case, it's radical 3. And remember, in order for me to keep my equation balanced, I got to multiply the same thing top and bottom. So I'm going to multiply those straight across, and I'm going to get 12 times the square root of 3, because remember, a whole number and a square root, they don't interact, over the square root of 9, because the square root of 3 times the square root of 3 is the square root of 9. And see, that equals 12 times the square root of 3 over 3, because the square root of 9 is 3. But see, the final thing here is that can, shoot, I forgot this is equal C. So the last thing about this is that if I have a fraction, you always reduce it. And 12 is outside the square root. 3 is outside the square root. So 12 divided by 3, I can do that. 12 divided by 3 is 4. So that means 4 times the square root of 3 is going to be equal to c. So now I know my c. Or in this case, it's my y. That's 4 square root of 3. That value is that value. Boom. So now I know that one. So y is equal to 4 times the square root of 3. Well, this value, which in this case is x, is 2 times c. So 2 times c equals 2 times 4 times the square root of 3. Well, the numbers are on the outside, 2 and a 4, so I'll multiply those two numbers. 2 times 4 is 8, right? So you know what? I don't want to yeah, well, that's fine. I'll just leave it like that. So 2c, I'm not, so 2c, this one, is going to be 8 times the square root of 3. So in this case, x is going to be 8 times the square root of 3. So see, that's what happens there, okay? That's how I use the special triangles to figure it out. Now I got a similar thing going on over here. So let's first talk about what we got. So I've got a, you know what? Let's not do that. Let's do a few adjustments. Okay, let's not do that. Let's do this. We got enough room. So let's go down and let's draw our triangle again. It is, this is a 45, 45, 90. This is y, this is x, and this is 6. So like I said, this is a 45, 45, 90 triangle. So let's talk about what the little the pattern looks like. So I got my 90-degree angle. I've got 45 here and 45 here. So what does it look like? Well, the two lengths are what I base my sides on. It just so happens that when you're dealing with triangles, that when you have the same angles like this, that usually means that your sides are the same. So I'm going to call this D and I'm going to call this D because these two sides are the same length. And so this right here is going to be D times the square root of 2. So let's give you a quick example. Just a quick and dirty example. If I had a 45, 45, 90 triangle and I knew that this side was 5, well, let's make it 6. Let's not make it 6. I don't want to be confusing. Fine, let's make it 10. Okay, so this is 10. So based on this, that means this side length is 10, right? And then this one is 10 times the square root of 2. And so that's how I would do it, you know? So Let's get this out of here. That's the easy way to do it. Now we're going to do the more challenging way. If we give you d, then it's easy. You just multiply d times the square root of 2. But if we give you this one, you're going to have to do some equations. So 6 is in the spot across from the right angle. So that means 6 is going to equal d times the square root of 2. So that's not going to work. So I need to divide by the square root of 2. These two things are going to cancel off. And I'm going to get 6 over the square root of 2 equals d. So now I need to get rid of this square root of 2. So I'm going to take 6 over the square root of 2, and I'm going to multiply the square root of 2 top and bottom. So remember, we're dealing with fractions, so we can do this. Now, why did I pick the square root of 2? Because the square root of 2 times the square root of 2 is a square, that's a little too close. Square root of 2 times the square root of 2 is the square root of 4, right? And so then I've got 6 times the square root of 2 over the square root of 4, which equals 6 times the square root of 2 over 2. And then I just solve that. So 6 divided by 2 is 3. So that's 3 square root of 2 equals d. So now I got my d. So when I look, d, or x, is going to be 3 times the square root of 2. And then what's y going to be? Oh, y is also d. So y equals 3 times the square root of 2. So when you find the one length, when you find that d, it's the answer for both of them. All right, so that's the first page. I'm going to end this video, and then we'll get to the next page.